Right, hello, welcome to my video. My name is Baihaqi Hakim. You can call me Hakim. And I take the study program of electronics instrumentation as an international undergraduate program in Universitas Gadjah Mada. And in this video, I'll be showing you my microcontrollers final project. In this project, I used a PIC 16F877A microcontroller and a temperature sensor to make a digital thermometer. So now let's move on to showing you the PIC 16F877A microcontroller project. Okay, so now you're looking at my microcontroller project, and let me briefly explain what you're looking at. So this white piece is called the breadboard. So everything is connected onto this breadboard, and the next important piece is the microcontroller here. It's a PIC 16F877A. That's what we're using in our class and for this project. And this whole system here is for a digital thermometer. So basically this part here is a 16:2 LCD. So there's going to be 16 across and 2 rows, which is why 16:2 LCD, and these are all connected to the circuit, such as to the power outputs and to the PIC. This here, as you can see, is the LM35 temperature sensor, and this one is a voltmeter to measure the voltage that is flowing through the system. And there is a red LED here, which is used to indicate if there's any power going through it or not. Here, this part is for a 12 volt. This is a 12 volt power supply connection to the breadboard. You can either use a USB or power supply using a DC jack input. On this breadboard, all the components are connected to the middle, and the two rows on each side, which is 1, 2, and 3, 4. These 2 rows on each side are used for the power supply, specifically for the positive and negatives. So positive, negative, all the connections in the middle, and the positive and negative. So this is how my circuit is connected. And this here is a 10k ohm rotary potentiometer. So you can turn it to adjust the resistance. So we will try to keep it at around 10k, and this here is connected to the grounds and positive, but also to the LCD. And what does that do? It adjusts the contrast of the LCD. And this one, of course, displays the voltage flowing through, which is also protected by a resistor. And here is all the connections, and we have some, if you look closer, there are some capacitors. Here there is a 10k ohm resistor, and here there is a 22 picofarad capacitor, specifically a ceramic capacitor. This metal piece here is a 20 megahertz oscillator, frequency oscillator, and there are some connected to the wires that are connected to the negative. That means that they're connected to the ground, and there's some connected to the positive for power. The whole system runs on basically 5 volts. And here's the connection of the ports if you want to see. Basically on the left side of the PIC, left side is pin 1 all the way till 20 on the left side, and on the right side is pin 20, if you can see it, pin 20 all the way to pin 40. But of course not everything is connected, because it's not required to connect all of them for this project. And if you look to the side, you can see connections on the 2 rows of each side. Here too. This is for the power, and the power supply I'll be using is this. It's a power supply adapter. You can adjust it, and you use this as the connections, and it will go through this port here. So you just connect it just like that. Let me just show you the program. So now we look at my program that has been used for this digital thermometer project. And as you can see here, we are using the program Micro C Pro for the coding part. So as you can see here, I've defined the frequency to be running at 20 MHz. These are defining the ports, and here it's to connect the ports of the LCD to the microcontroller port, this port, and this is to set the direction down here. And then we use integer temp for the temperature and temper for temperature output. And this void read temperature is a function to read the temperature that is detected from the sensor. Then next we move on to data conversion to convert the values. And here is the function to display. And in this case, we want to display what should appear in our LCD is this temperature equals, and then the temperature, which is the value, the number, along with degrees Celsius. And this is the main program. It's pretty simple. That's it. That's the program. And as you can see here, it's pretty simple. And if you click build, it says finished successfully, meaning that there's no errors and everything works. And of course, I've set the frequency here too on the left side, along with the right microcontroller. So now we move on to how the program is flashed onto the microcontroller. So I used the program MPLAB IPE. That's what I found that worked. So how the program works is how you connect the Picket3 programmer to the computer and make sure your microcontroller is on the Picket3. So use this program, and then you go to device and select the microcontroller that we are using. And then you click apply, and then after that you select the tool, and in this case the computer detected Picket3, so you connect it. After you connect, everything will load up, and then your next thing you do is you open up your hex file where your micro C project was saved. And then after the hex file is selected, you click program. After you program, the code will be flashed onto your microcontroller, and then that's it. That's done. So after showing the program and how it's being flashed, now I'll connect this to my power outlet. Okay, now it's connected. So the power goes through here to the 12-volt regulator for the breadboard, and then power is supplied on the two sides of the breadboard, and the wires connect them to the components. That's basically it. So to turn it on, you press this switch here. The green light indicates that it's on, and so does the red light. This is the LM35 sensor. This is the voltage that is flowing through, and this regulator accepts a voltage of up to 12 volts. We only require 5 volts of power. And this is the screen, which is the LCD 16:2 screen, and it's supposed to display the temperature that is being detected from this LM35 sensor. So this is the LCD screen. As you can see, the screen works, but for some reason it doesn't show the text that has been made from the program. I am not sure why, but if you use the rotary encoder, let me just spin it around, it will adjust the contrast, so it will become very light and then very dark, as you can see here. There is a problem where it won't show any text at all. However, in the program, when you run the program, it shows that there is no error whatsoever and it's working. And then when you flash it, it's flashed successfully, and then I've verified it that this has been flashed successfully. So program works, it has been flashed, microcontroller has been flashed successfully, so there's no problem there. But it still won't show the text or anything. See, there's no text. It's supposed to show like temperature equal to how many degrees Celsius, but there is power here. There's 4.99 volts of power. And yeah, this is where I've reached for my microcontroller project. So that's it for my microcontroller project. Have a nice day.